Welcome back. We're going to be building off of what we learned in the last video, and now we're going to be talking about molecular and formula mass. And we've already seen something similar before. We've looked at atomic masses, and those are the masses of atoms of an element. And we saw that it's the number of protons plus the number of neutrons. And when we look at the periodic table, we could find the atomic mass of an element listed here. Okay, it's in the bottom of the box, the box for each element on the periodic table. So like I said, we've seen this before, and we're going to use that knowledge and the knowledge we learned in the last video to find the mass of molecules in ionic compounds. Okay. So molecular mass or formula mass is the mass of a given molecule. And so how we calculate that, the formula mass is the sum of atomic masses in the formula unit, okay? And just as something to be aware of, the term formula mass is kind of broad. It can be used for ionic or molecular compounds, but it's must be used for ionic compounds. We don't really call the molecular mass or use the term molecular mass when referring to ionic compounds. It's not, I won't really try to trick you up there on the quizzes and tests. I'll be listing that, making it clear, but just be aware of that. And either way, it's the sum of the masses in the formula unit, okay? So for example here, we have carbon dioxide, okay? Carbon dioxide molecule. So its molecular mass, okay, shown here, or formula mass, is the sum, okay, of the atomic masses for oxygen and for carbon. So that's how we're going to do these problems. We're going to find how many atoms of each element we have. We're going to find their atomic masses, and then we're going to add them all up basically to get the formula mass. So let's just do an example problem. What is the formula mass of calcium phosphate? Well, again, now we have to recognize that we need to be good at naming and writing down the formulas of ionic compounds. It's going to keep coming back. So if you're having trouble with that, go back to those videos on naming ionic compounds and writing their formulas. So for here, for calcium phosphate, okay, we have a calcium ion. And if you look on your chart on polyatomic ions, this is the phosphate anion. Again, you cross their charges. So you get calcium, put in parentheses that polyatomic ion, 2. Okay. So this is our formula for calcium phosphate. So now, like we did in the last video, I need to write down how many atoms of each element I have of calcium phosphate. So let's do that. So again, just list everything we have here. We have calcium, we have phosphorus, we have oxygen. For how many of each I have, for calcium, I have 3. Okay, that indicates I have 3 calcium atoms here. For phosphorus, I'm going to have 2, right? So 1 times 2. So I have 1 times 2. And then for oxygen, okay, I'm going to have 8. So there's 4 times 2, 8. Okay, so that's how many of each I have. And let me just make these all the same color, because that's going to bother me. Okay, so I have 3 of these guys. All right, so now we have written down how many of each we have. Now what you can do is go to a periodic table, okay, and look up the atomic masses for each one of these elements. And what I like to do is round to 2 decimal places. That's pretty reasonable, I think, to do. So some of them you don't have to list out all the decimal places for the atoms, just go to 2 decimal places. So when I do that, I'm going to just write that right next to these numbers here. Okay. Calcium, its atomic mass, what I have written down at least, I hope it's right, is 40.08. This is going to be units of U. Okay. Phosphorus, 30 4.97. Oxygen is basically 16 when you round it to 2 decimal places. Okay, and what you're going to do, you're just going to multiply the number of atoms that you have by the atomic mass of that atom, okay, for that element. So when you do that, this is what you should get. So 120.24, that's what I have here, 61.94, and about 128.00. Okay, so let's add this up. And when I do, I get 310.18 U. So this is the mass, okay, the formula mass of calcium phosphate. Okay, this is the formula mass. All right. So that's how you're going to do these problems. Again, you find out the formula for what you're looking at. You write down the number of atoms of each element in that formula. You find the atomic masses on the periodic table. Okay. You multiply the number of atoms of each element by its atomic mass, and then you add up the sum. Okay. So let's do some more examples together so it becomes more clear if it's unclear right now. Okay. So this is just rounding. Round off the answer to the same number of decimal places as the smallest number of decimal places in any atomic mass used in the calculation. Basically, we're still going to use the sig fig rules for addition and subtraction here. So if, you know, transporting back, remember I said in that chapter that sig figs are going to be really important going forward. That's still true here. Okay, so like I said, I like to, this last statement here, what I would really say is you can just round the atomic masses on the periodic table to 2 decimal places. I'm pretty happy with that in the problems and the homework. So that's what I would suggest doing. Okay, so it might be saying something a little bit different here, but just do 2 decimal places and that will be fine. Okay, so let's do some examples. So what I suggest is you pause the video and do these examples on your own. And then we're going to come back and we're going to do them together. Okay, so I'm going to go a little quicker now. And again, we're going to write down the formula first. So this is the formula for ammonium nitrate. Again, I'm going to write down how many of each element I have right here. So I have 2 nitrogen atoms, 4 hydrogen atoms, and 3 oxygen atoms here. So hopefully you wrote down the same thing, okay? Just again, counting up, in this case, the using the subscripts to count the number of atoms. And then I go in the periodic table and I write down the mass of each element. So that's the atomic mass for nitrogen. That's the atomic mass for hydrogen. And we've already seen the atomic mass for oxygen. Okay, I multiply these 2 numbers together. So here I get 28.02, 4.04, and I get 48. Okay. I add all those up and I get 80.06 U. And that's the unit we're going to be using here when we're talking about formula mass or molecular mass. Okay. So hopefully you got the same answer. That's how we're going to do these problems together. And I'm just going to recheck my work here. And if you haven't already, like I said, why don't you do the next few problems as I plug this in my calculator. Okay. Yep. Okay. So that's the right answer. Okay. So next one, always want to double check your work. Even me, sometimes I put these notes together before bed and I just got to see if I was thinking correctly at the time. Okay. So here we go. This one's easy. We are given the formula. So we write down each element. Okay, then we get its atomic mass off of the periodic table. Okay, when we do that, this is what I get. (180.18 U). Okay, so that's the formula mass of this compound. The last one's pretty easy. We're given the atoms already. We have 2 of them. So we have basically 2 chloride atoms, or chlorine atoms, rather, times the atomic mass, 35.45. So it's equals 70.90 U. Okay. So hopefully that made sense. And in the next video, we're going to be talking about the mole concept. So I will see you there.